Welcome back. Episode 5, Standards, the IANA Object Identifier, and the OpenSSL walkthrough. Today we look at why an algorithm needs a registered identifier, how Ladhe got one, and how it shows up in OpenSSL.
What is an object identifier? An OID. It is a globally unique number that names a thing in a hierarchical namespace. Some you have already seen without realizing. 1.2.840.113549 is RSA encryption. There is one for elliptic curves, and one for MLDSA65. Every cryptographic algorithm in standard use has an OID. Without one, no standard parser can recognize it.
Why does Ladhe need an OID? An X.509 certificate has fields for the public key algorithm and the signature algorithm. Both of those fields contain an OID. Without a registered OID for Ladhe, no third-party tool could parse a Ladhe certificate. As a Ladhe certificate, it would just see unknown algorithm and reject it. An OID is the entry ticket to the existing PKI ecosystem.
How do you get an OID for a brand new algorithm? Through IANA, the Internet Assigned Numbers Authority. IANA issues Private Enterprise Numbers, or PENs, to organizations. Each PEN gives you a slice of the global OID tree. Within that slice you can mint as many sub-OIDs as you need. PENs are free. They take a few weeks to assign, and last forever. This is how every serious vendor, Cisco, Microsoft, RSA, anchors its proprietary identifiers.
IANA assigned PEN 65644 to LeSecure on April 23, 2026. From that we minted 3 OIDs. ID Ladhe signature for signatures, ID Ladhe public key for public keys, and ID Ladhe cert v1 for the certificate format. These are the exact strings you saw in episode 4, when OpenSSL read Alice's X.509 certificate.
OpenSSL ASN1 parse walks the raw ASN1 tree. Run OpenSSL ASN1 parse on Alice's X509 cert. You will see the structure unfold, and you will see 1.3.6.1.4.1.65644.1.1 appear as the object in the signature algorithm slot. That is Ladhe. Standard tool, standard parse, recognizes Ladhe by OID.
For a more human-readable view, run OpenSSL X509 text. You see the certificate as a structured document, issuer, validity, subject, public key, all of it standard X.509, with Ladhe's OIDs in the algorithm slots. This is the same output a network engineer would see for any TLS certificate.
Having an IANA OID is the first step. It is not the last. Right now we have a registered OID and an open implementation. Next, the scheme needs community cryptanalysis. That is essential. Then would come an IETF, algorithm identifier draft, and eventually, NIST evaluation. If the scheme survives community review, we are at step 1. Help with steps 2 through 4 is welcome.
Up next, episode 6, for cryptographers, we will tour the paper and the code, show you the cryptanalysis challenge generator, and explain exactly what would constitute a break. If you break Ladhe, we want to hear from you. Thank you for watching.